Hello there and welcome to the channel. You've got nothing to do right now except rest. Let your mind relax and become calm. Let your breathing slow down and become steady. Let your body grow light and comfortable as if gravity itself has become softer and gentler around you. Get comfortable in your bed or on your couch. Pull up your blanket if you need to. Close your eyes if that feels good. Because tonight, we are not simply looking at stars through a telescope. We are drifting slowly through our home galaxy, the Milky Way. The Milky Way is a vast spiral made of stars, dust, gas, and something called dark matter. It has been turning slowly in space for over 13 billion years. That is older than almost anything we know, but beneath all its beauty, there are secrets hiding in the darkness. There are rogue stars flying away at incredible speeds. There are invisible forces holding everything together. There are ancient remains of stars that challenge what we thought we knew about how galaxies form and grow. Tonight we will travel gently from the bright spiral arms where new stars are being born, all the way to the hidden core at the very centre, where a giant black hole sleeps quietly. We will learn about colossal collisions that happened billions of years ago. We will hear about stars that are older than the galaxy itself. We will discover black holes and stellar nurseries and the strange, unfinished story of a galaxy that is still growing even today, even right now as you listen to these words. Some of what you hear tonight might surprise you. Other facts might make you curious or make you wonder about your place in this enormous universe. But most importantly, I hope these gentle cosmic explorations help you unwind and relax. I hope they give you a quiet, peaceful way to end your day and drift off into a good night of sleep. And just before we begin our journey through the stars, if these calm and curious explorations help you feel peaceful, or give you something interesting to think about as you fall asleep, consider pressing the like button and subscribing to this channel. It really helps other people find their way here too, one sleepy soul at a time. We are building a little community of people who love falling asleep to the wonders of science and space. Now let your shoulders drop. Let your jaw relax. Let your thoughts begin to drift like clouds moving slowly across a summer sky. We are about to begin our gentle journey through the Milky Way galaxy, and you do not need to remember every single fact. You do not need to stay awake. Just let the words wash over you like a soft tide, carrying you towards sleep. Let us begin. Fact 1. The Milky Way has already crashed into other galaxies in the past, and it will crash into another galaxy again in the future. Our galaxy might feel like a stable and permanent home when you look up at the night sky, but the truth is that it was built from the wreckage and remains of other smaller galaxies. Over billions and billions of years, the Milky Way has pulled in and absorbed smaller galaxies that wandered too close. It draws them in with its powerful gravity, then slowly unravels them and scatters their stars into long ribbons called tidal streams. These streams wrap around the disk of our galaxy like ghostly ribbons in space. One such galaxy, called the Sagittarius Dwarf Galaxy, is being pulled apart by the Milky Way right now, at this very moment. And far off in the night sky, another huge galaxy called Andromeda is drifting slowly closer to us. In about 4.5 billion years from now, these two great spiral galaxies will merge together in a cosmic collision. The stars themselves will almost never actually hit each other, because space is so vast and empty, but the shapes of both galaxies will change forever. They will fold and twist into a new form, something vast and quiet and different. Even galaxies, as permanent as they seem, are not eternal. They evolve over time. They collide with each other, and they begin again in new forms. Fact 2, some of the stars in the Milky Way are actually older than the Milky Way itself. That might sound impossible at first, but it is true. Not every single star that exists in the Milky Way today was actually born here in this galaxy. Some stars, especially very old ones called halo stars, appear to have formed even before the Milky Way had fully taken its shape. These ancient stars are called metal-poor stars because they contain almost no heavy elements like iron or carbon. Astronomers believe these stars might have been born in smaller, more primitive galaxies that existed right after the Big Bang, and then later those tiny galaxies merged together with our own galaxy billions of years ago. The stars got absorbed into the Milky Way during those ancient collisions. You can identify these elder stars by studying their chemical fingerprints, which show they contain almost nothing except hydrogen and helium, the simplest elements in the universe. These stars move slowly through space on long, tilted orbits that carry them high above the flat galactic plane where most stars live. They are like elder spirits from a time before spirals existed, before there was any order in the universe. In their faint light, we glimpse a universe that was younger, wilder, and still learning how to become what it is today. Fact 3. Our solar system, including Earth and the Sun and all the planets, is zooming through space at over 828,000 kilometers per hour. That is more than 230 kilometers every single second. The solar system is racing around the center of the Milky Way galaxy at this incredible speed, and yet even moving that fast, it still takes about 225 million years to complete just one single loop around the galaxy. This incredibly long journey is called a galactic year. In Earth time, measured by our regular years and calendars, we have only gone around the Milky Way about 20 times since the solar system first formed 4.5 billion years ago. Think about that for a moment. When the very first dinosaurs appeared on Earth and started walking around, we were in a completely different part of the galaxy. The stars that we see shining in the night sky today were not always our nearby neighbours, and they will not always remain close to us in the future. Everything in the galaxy is moving. Everything is in motion. Quietly, slowly, endlessly, things are drifting and orbiting and travelling through space. Even as you sleep tonight, the Earth is turning on its axis. The Moon is circling around the Earth, and the entire solar system is sweeping forward through a galaxy that is itself in constant motion. Fact 4. The Milky Way galaxy is still growing larger even today. Although the galaxy is incredibly ancient, more than 13 billion years old, it is not finished yet. Even right now, at this very moment, it continues to gather new material from space. It pulls in gas from something called the intergalactic medium, which is the thin soup of matter that exists between galaxies. It captures stars from smaller dwarf galaxies that wander too close and get trapped by gravity. And it draws in streams of dark matter that feed into its halo. The huge sphere of invisible matter that surrounds the visible part of the galaxy. The Milky Way grows not like a living creature grows, but like a gravitational structure that deepens and expands over enormous amounts of time. Some of this growth happens very quietly and gradually through gas slowly filling in empty spaces. Other times, growth comes with disruption and violence as entire satellite galaxies get torn apart and scattered, and their stars get flung across the sky in all directions. The galaxy you are living in right now tonight is not exactly the same galaxy that the dinosaurs saw when they looked up at the sky, and the galaxy that your distant descendants might know millions of years from now could be even larger still, stitched together from the ruins of 1,000 smaller worlds that got consumed along the way. Fact 5. We actually do not know for certain how many spiral arms the Milky Way has. It seems like something we really should know, right? How many arms spiral outward from the centre of our own home galaxy? But the truth is that from our position deep inside the disk of the galaxy, it is extremely hard to see the whole structure clearly. Thick clouds of dust obscure and block our view of distant regions. Stars blur together into one another when we try to look through the galaxy. For many decades, astronomers believed there were 4 major spiral arms curving through the Milky Way. But more recent observations using better telescopes have suggested that maybe there are fewer arms than we thought, or that the arms twist and split and branch in ways that are far more complex than we expected. Some arms seem to fade out into fragments as they stretch away from the centre. Other arms wrap around in unexpected directions that do not match our models. The Milky Way may not be a neat, perfect pinwheel shape at all. Instead, it might be a living, layered swirl of stars that is shaped by forces and processes that we still do not completely understand. Fact 6. Some stars get flung out of the galactic core at tremendous speeds. Most stars drift calmly and peacefully through the galaxy on stable orbits that last for the billions of years. But a rare few get thrown outward at absolutely astonishing speeds, moving fast enough to escape the entire Milky Way galaxy and fly off into the darkness beyond. These incredibly fast-moving stars are called hypervelocity stars. Scientists believe that some of them are the remnants of binary star systems, which are pairs of stars that orbit each other. If one of these pairs wanders too close to the supermassive black hole at the center of the galaxy, something dramatic can happen. The intense gravity near the black hole can disrupt and break apart the binary system. One star might fall inward toward the black hole and vanish forever behind its event horizon. Meanwhile, the other star gets flung outward like a stone from a slingshot, hurled into the darkness at speeds of over 1 million kilometers per hour. These rogue stars travel completely alone, far above and below the flat galactic plane, where most stars live. They move through space like glowing comets, with no possibility of return, racing away from their birthplace forever. They remind us that even in a galaxy that is mostly bound together by gravity and order, there are moments of violent release and chaos. There are quiet expulsions that send stars flying away into the intergalactic night, never to return home. Fact 7. The Milky Way and the Andromeda Galaxy are on a collision course with each other. High above the horizon on autumn nights, if you look carefully in a dark location far from city lights, you can see the Andromeda Galaxy as a faint blur. It is a beautiful spiral galaxy, much like our own Milky Way, lying over 2 million light-years away from us. And yet despite that enormous distance, Andromeda is moving steadily toward us through space. In about 4.5 billion years from now, these two massive galaxies will collide with each other. But the collision will not be violent in the way you might imagine from science fiction movies. Stars are spaced so incredibly far apart from each other that they will almost never crash directly into one another. Instead, the gravity of both galaxies will warp and stretch them into long, reaching arcs and shapes. Tidal tails made of streams of stars will curl outward into spacetime. The supermassive black holes at the center of each galaxy may slowly spiral together over millions of years. And after billions of years of this cosmic dance, the two galaxies will finally merge completely into a single larger system. Astronomers have even given this future merged galaxy a name already. They call it Milky Way. It will be a slow, elegant dance between two giants. The future of our home is written across the stars, approaching slowly but inevitably. Fact. Some stars in the Milky Way orbit backward compared to most other stars. The vast majority of stars in our galaxy orbit the galactic center in roughly the same general direction, all flowing together like traffic on a cosmic highway. But not every star follows these rules. Some stars, especially those found in the outer halo region far from the main disk, move in what astronomers call retrograde orbits. This means they are travelling in the opposite direction compared to most other stars. They are swimming against the current. These backward moving stars almost certainly arrived from somewhere else. They were likely born in small dwarf galaxies that later got absorbed and consumed by the Milky Way during ancient mergers billions of years ago. Their reversed motion through space is like a quiet signature of their foreign origin, a clue written in movement. It is as if the galaxy carries old memories embedded in the motion of its stars. These orbits are stories of ancient mergers and cosmic encounters, preserved not in light or colour, but in the slow, patient turning of stars moving against the stream of traffic, forever marked as strangers in their adopted home. Fact 9. The Milky Way has probably eaten and absorbed dozens of smaller dwarf galaxies over its lifetime. Our galaxy did not grow alone in isolation. Over billions of years, it has consumed other galaxies. Small galaxies and faint companions have drifted too close to the Milky Way, gotten caught in its powerful gravity, and been slowly taken apart and dismantled piece by piece. Their stars are now scattered throughout our halo, our disk, and in long stellar streams that wrap around the galaxy like ribbons. Astronomers have identified several of these ancient merger events by carefully analysing the motion and chemical composition of stars. One especially large merger event, called the Gaia-Enceladus merger, happened billions of years ago and added an enormous number of stars to our galaxy. It may have even reshaped the early structure of the Milky Way, changing its fundamental form. The Milky Way is not a pristine, perfect spiral that has remained unchanged since it formed. Instead, it is a composite structure, built and assembled from quiet collisions over time. It has been stitched together like a quilt from the remains of many smaller worlds that got torn apart and absorbed into the larger whole. Fact 10. The chemical makeup of a star reveals where it came from and when it was born. Every single star in the galaxy carries what astronomers call a unique chemical fingerprint. This fingerprint is a pattern of elements that was imprinted into the star at the moment of its birth. Some stars are very rich in heavy elements like iron, calcium, and nickel. This suggests they formed in dense regions where many earlier generations of stars had already lived and died, enriching the surrounding space with heavy elements created in supernova explosions. Other stars contain almost nothing except hydrogen and helium, the two simplest and lightest elements in the universe. These metal-poor stars were born when the universe was still very young, before there had been time for many stars to explode and create heavier elements. By studying these chemical signatures in starlight, astronomers can group stars into families. They can uncover evidence of ancient galactic mergers, and they can reconstruct the hidden story of how the Milky Way formed and evolved over billions of years. In this way, chemistry becomes a kind of time machine for astronomers, letting them read a star's past like a line of ancient poetry written in light and captured in the spectrum of colours that the star emits. Fact 11. The night sky is full of thin ribbons called stellar streams, which are the remnants of galaxies that got shredded apart. Across the sky, barely visible even with powerful telescopes, there are thin ribbons of stars stretching out in long arcs and elegant curves. These delicate structures are called stellar streams. They are the remains of smaller satellite galaxies that wandered too close to the Milky Way millions or billions of years ago and were pulled apart by tidal forces. As these doomed galaxies orbited around the Milky Way, the difference in gravitational pull on their near side versus their far side slowly stretched them out. Their stars got smeared across space in long, trailing lines that trace out their former orbital paths like ghostly halos. Some of these streams wrap completely around the galaxy in graceful loops. Others dive inward toward the core of the Milky Way. Each stream is evidence of a past collision, a quiet merger that happened long ago and helped build the Milky Way over billions of years into what it is today. The galaxy is like a great tree, and these stellar streams are like the rings inside the trunk. They tell us about the past. They carry the history of the galaxy written in the positions and motions of scattered stars, each one a fragment of a world that no longer exists. Fact 12. The disk of the Milky Way is warped and bent, not perfectly flat like you might expect. Our galaxy does not lie completely flat like a perfect dinner plate, or a neat spiral you might draw on paper. Instead, the disk of the Milky Way bends upward on one side and downward on the other side, forming a graceful wave pattern across space. For a long time, this subtle warp was completely invisible to astronomers. They could not detect it using regular telescopes that observe visible light. But eventually, radio telescopes that can detect hydrogen gas allowed astronomers to map regions far beyond where most stars shine. That is when they discovered the warp zone. Scientists believe this distortion might be caused by the gravitational pull of smaller satellite galaxies that orbit around the Milky Way, tugging gently on its edges like hands pulling on the rim of a spinning plate. Or it might be caused by invisible clumps of dark matter that are bending the structure from below, warping space itself, like ripples spreading across the surface of a pond or waves moving through a great spinning sheet. This warp reveals that even enormous galaxies are never completely still or rigid. Over vast stretches of time, they bend and flex and change their shape in response to invisible forces acting on them from all directions. Fact 13. If someone could see the Milky Way from very far away, from outside the galaxy looking in, it might look like the galaxy is dancing slowly and gracefully through space. With the naked eye from Earth, you can only see about 0.00003% of all the stars in the Milky Way galaxy. Under a perfectly clear and dark sky, far away from cities and streetlights and light pollution, you might be able to see a few thousand individual stars with your eyes alone. To most people, that seems like an absolutely enormous ocean of light spread across the heavens, but compared to how many stars actually exist, it is barely even a single droplet. The Milky Way contains well over 100 billion stars. Some estimates suggest there might be as many as 400 billion stars in the galaxy. Most of these stars are completely hidden from our view. Some lie behind thick, dark curtains of interstellar dust that block their light. Others are simply too faint or too far away for human vision to detect them. The pale streak of light that we call the Milky Way, which crosses the night sky on moonless nights in summer and winter, is really just the innermost whisper of the galaxy. It is just the brightest, nearest, most visible parts. We live completely surrounded by an enormous river of starlight, and yet almost all of it remains invisible to us. The galaxy is far too vast to fully grasp from our position inside it. Fact 14. Stars in the Milky Way orbit the galactic center at many different speeds depending on where they are located. Unlike the planets in our solar system, which all follow neat, predictable paths around the Sun according to simple laws of motion, stars in the Milky Way move with much more freedom and complexity. Some stars race ahead quickly in the crowded inner regions near the galactic center. Other stars drift along slowly at the outer edges of the disk, taking hundreds of millions of years to complete a single orbit. This difference in orbital speed from place to place is actually why spiral arms can form in the first place. The arms are not solid, rigid structures made of the same stars all the time. Instead, they are temporary patterns, like slow traffic jams where stars and gas clouds bunch up as they move through space at different speeds. These bunched up regions are called density waves. As stars and gas pass through these waves, conditions become right for new stars to form, which lights up the spiral arms in beautiful curls of blue and white light from young hot stars. Our own Sun is part of this great swirl, slowly moving in and out of these density wave patterns across enormous stretches of time as it orbits. The galaxy is not like a clock with gears that all move together in perfect synchronization. It is more like a current in a great cosmic river, and we are drifting along in it. Fact 15. The Milky Way galaxy holds itself together because of something mysterious that we cannot see with any telescope. By all normal logic and all the laws of physics that we understand, the Milky Way should not be able to exist in its current form, based on everything we can actually measure directly. Like stars and dust and gas clouds, the outer edges of the galaxy are spinning much too fast. The stars out there should be flung off into empty space and scattered in all directions, like mud flying off a spinning wheel, and yet somehow, impossibly, they remain in place, orbiting steadily. The answer to this mystery is something called dark matter. This mysterious substance does not shine or glow. It does not reflect light. It does not emit any kind of radiation or energy that we can detect with our instruments. But it does create gravity, and apparently there is so much dark matter in and around the Milky Way that it outweighs all the visible matter, all the stars and gas and dust combined, by many times over. We still do not know what dark matter actually is. We do not know what it is made of. We cannot see it or touch it or interact with it in any way except through gravity. But we do know that without dark matter acting as an invisible glue, the Milky Way would simply fly apart and cease to exist as a galaxy. Dark matter is the hidden scaffolding that holds the entire structure together. Fact 16. At the very center of the Milky Way, deep in the galactic core, there is a supermassive black hole lurking in the darkness. At the exact center of our galaxy lies an object of truly staggering mass and density. It is a black hole, a region of space where gravity is so incredibly strong that nothing, not even light itself, can escape once it crosses a boundary called the event horizon. This particular black hole is called Sagittarius, a star, and it is absolutely enormous. It contains more than 4 million times as much mass as our entire Sun, all compressed down into a region of space that is smaller than the orbit of the planet Mercury. We cannot see this black hole directly because, by definition, black holes do not emit light. But astronomers have watched nearby stars whipping around it at tremendous speeds, tracing out invisible loops through empty-looking space as they orbit the unseen monster. Sometimes clouds of gas and dust fall inward toward the black hole and get heated to incredible temperatures as they spiral down. When this happens, the material flares brightly with X-rays just before it vanishes forever. Right now, Sagittarius, a star, is relatively quiet and sleeping. But long ago, in the distant past, it may have been much more active, perhaps even burning like what astronomers call a quasar, and lighting up the entire galaxy from within with brilliant, violent radiation. It sits there in the dark like a silent conductor, pulling and pushing on nearby stars, forcing them into an endless gravitational dance around the galaxy's hidden heart. Fact 17. The central bulge at the core of the Milky Way has a strange peanut shape when viewed from certain angles. When astronomers carefully mapped the center of the galaxy using infrared light that can penetrate through dust, they discovered something quite unexpected about its structure. The central bulge, the densely packed ball of stars at the very middle of the galaxy, is not a smooth round sphere like you might expect. Instead, it has an unusual three-dimensional shape that looks remarkably like a peanut still in its shell. If you could view it from the side, edge on, you would see that it swells outward in the middle and narrows at both ends, creating an hourglass or peanut silhouette made entirely of countless stars. This strange and surprising geometry probably formed over billions of years from something called the galactic bar. The bar is a dense, elongated stripe of stars that stretches across the central region, rotating slowly. Over enormous amounts of time, the rotation and gravitational forces cause this bar to buckle and puff upward and downward, creating the peanut shape we observe today. These inner structures of the galaxy are sculpted by gravity acting over billions of years, shaped by the accumulated rhythm of countless stellar orbits all influencing each other. We live in what we call a spiral galaxy, but when you look closely at its heart, you find that it is full of unexpected complexity. The core is not flat or clean or simple. It is intricate, layered, and very much alive with motion. And 18. The beautiful spiral arms of the Milky Way are not simply made of stars arranged in a pattern. They are actually woven from the birthplaces where new stars are constantly being created. Giant clouds made of hydrogen gas, dust particles, and complex molecules drift slowly through the galaxy. These clouds can be absolutely enormous, spanning hundreds of light years across space. When these massive clouds pass through the density waves that create the spiral arm patterns, they get compressed and squeezed by gravitational forces. This compression causes them to collapse inward, and this collapse triggers the birth of brand new stars. These stellar birth regions are called stellar nurseries, and they are chaotic, glowing, and full of motion and energy. The ultraviolet light from newly formed hot stars lights up the surrounding clouds of gas, painting the spiral arms with radiant blues, purples, and silvers. These bright bursts of star creation trace out the beautiful spiral shape of the galaxy, illuminating its curves with what looks like quiet fire burning in space. Every single star that exists today, including our own sun, was born billions of years ago from one of these cloudy cradles, deep inside a stellar nursery where gravity slowly pulled matter together until fusion ignited and a new light appeared in the cosmos. Fact 19. Beyond the flat spiral disk that contains most of the visible stars, the Milky Way is surrounded by something much larger and more mysterious called the galactic halo. This halo is an enormous, roughly spherical cloud of material that completely surrounds and envelops the entire galaxy. It contains some very ancient stars which are among the oldest objects in the universe. It contains structures called globular clusters, which are tight balls of hundreds of thousands of stars all bound together by gravity. And most importantly, it contains absolutely enormous amounts of dark matter, far more than exists in the visible disk. Though the halo is nearly invisible and almost impossible to see with regular telescopes, it may actually hold the majority of the Milky Way's total mass. Its stars are spread incredibly thin across vast distances, orbiting the galaxy in long, slow arcs that rarely come anywhere near the crowded disk where we live. The halo also preserves the remnants and leftovers of ancient galactic mergers from billions of years ago. You can find streams and shells of stars that were torn away from smaller galaxies and left behind like fossils made of light. The halo is the galaxy's outer memory bank. It is quiet and dim and sparse, but it is still slowly moving, still evolving, and still actively shaping what the Milky Way becomes over cosmic time. Fact 20. Scattered throughout the Milky Way's halo are over 150 compact spheres of stars called globular clusters. These globular clusters are among the very oldest objects that exist anywhere in the galaxy. Each one is a tightly packed sphere containing hundreds of thousands of stars, sometimes even millions, all bound together by mutual gravitational attraction. They orbit the galactic center in the halo region, far above and below the main disk, moving like moths slowly circling around a distant flame. These clusters are incredibly stable structures. Some of them are more than 12 billion years old, which means they formed when the universe itself was still very young. Many globular clusters contain stars that are actually older than the Milky Way's disk, meaning they existed before our galaxy took its current spiral shape. The stars inside them are what astronomers call metal poor, which means they formed before the universe had enough time to create many of the heavier chemical elements through stellar processes and supernova explosions. Globular clusters serve as time capsules from the early universe. They hold precious clues about how galaxies like ours formed in the first place, what the galaxy consumed and absorbed during its growth, and what conditions were like in the cosmos billions of years ago when everything was younger and stranger. These quiet, golden spheres drift patiently in the darkness above and below the galactic plane, glowing softly with the combined lights of their ancient suns. Fact 21. Star formation in the Milky Way is gradually slowing down compared to the distant past. Long ago, billions of years in the past, the Milky Way was a much more active and violent place than it is today. It was bursting with activity as enormous numbers of fresh new stars were born from dense clouds of gas that collapsed under their own gravity. But in more recent epochs of galactic history, the pace of star formation has been steadily declining and slowing down. There is still plenty of gas available in the galaxy that could potentially form stars, but much of it has become spread out too thin across space. Some of it has been heated to high temperatures by energy from existing stars and supernova, making it harder for gravity to pull it together. And some gas has been locked up in forms that naturally resist gravitational collapse. The Milky Way is definitely not done making new stars. Star formation still continues in many regions, especially in the spiral arms. But the galaxy is settling down and maturing. Astronomers estimate that the peak of star formation happened several billion years ago, and the rate has been gradually declining ever since that ancient era. This does not mean the galaxy is dying or that the end is anywhere near. It only means that we happen to live in a quieter, or more peaceful chapter of the galaxy's long story. The Milky Way is like a mature spiral glowing gently in its middle age, still creating new stars regularly, but no longer in any particular hurry to do so. Fact 22. Some of the oldest stars in the Milky Way actually formed before the galaxy even had a proper disk structure. The disk, which is the broad flat spiral that we usually think of when we picture the Milky Way, did not appear instantly when the galaxy formed. Instead, it developed gradually over hundreds of millions of years. But some of the stars in our galaxy today are even older than that disk structure. These incredibly ancient stars live mostly in the halo region or in what astronomers call the thick disk. And they formed during an earlier time when the galaxy was still assembling itself. Back then, the Milky Way was not yet a neat spiral. It was more like a loose cloud made of stars, gas and dark matter, all slowly collapsing inward under the pull of gravity. By carefully studying the chemical composition of these elder stars and by tracking their motions through space, astronomers can peer back into that era before structure and order emerged, before there were spiral arms at all. These stars are the true elders of the galaxy. They are silent witnesses to its birth and to the long, slow process of shaping and organizing that eventually created the beautiful spiral we call home today. Fact 23. The time it takes for the Sun to complete one full orbit around the Milky Way is called a galactic year, and it lasts between 225 and 250 million Earth years. And as our solar system travels through space, orbiting around the distant centre of the galaxy, it traces out an enormous circular path. Completing one full revolution around the galaxy takes an almost unimaginable amount of time. This vast cycle of motion is what astronomers call a galactic year. It is a measurement of time so large that it completely dwarfs all of our human calendars and history. In the span of a single galactic year, entire continents drift across the surface of Earth, colliding and separating. Mountain ranges rise up and then erode away. Species evolve, flourish, and go extinct. Entire geological epochs unfold from beginning to end. Astronomers believe that we are currently somewhere around the halfway point in one of these galactic orbits. The last time the solar system was in roughly this same part of its enormous path through the galaxy. The supercontinent called Pangaea had just begun to break apart into the separate continents we know today. Dinosaurs had not yet appeared on Earth. The galactic year is like the slow, steady heartbeat of cosmic time, a rhythm far too vast for human lifespans to perceive directly. Fact 24. In all of its 4.6 billion years of existence, our Sun has only completed fewer than 25 trips around the Milky Way galaxy. That might seem surprising at first. You might think that something as old as the Sun would have circled the galaxy hundreds or thousands of times, but the galaxy is so incredibly vast, and the Sun's orbital path is so enormously long that each complete orbit takes hundreds of millions of years to finish. Despite travelling at nearly 830,000 kilometers per hour through space, the Sun has made only about 20 or so full circuits around the galactic centre during its entire lifetime. We often think of stars as ancient and unchanging, fixed points in the sky that have always been there and always will be. But our solar system is actually still quite young when measured on the galactic timescale. We are relative newcomers in this city of stars. The Sun is still early in its long journey through the galaxy, still writing its path through space, still part of the Milky Way's ongoing motion and story. Fact 25. The way the Milky Way rotates actually defies what Isaac Newton's laws of physics predict should happen. According to classical Newtonian physics, which works perfectly well for describing how planets orbit stars, objects that are farther away from the centre of rotation should orbit more slowly than objects closer in. This is exactly what we observe in our solar system. The outer planets like Neptune and Uranus move much more leisurely in their orbits compared to inner planets like Mercury and Venus. But when astronomers measured how fast stars orbit at different distances from the centre of the Milky Way, they discovered something shocking and unexpected. Stars in the outer regions of the galaxy, far from the centre, orbit almost as quickly as stars that are much closer to the galactic core. This completely defies the classical predictions. The rotation curve, as astronomers call it, stays flat instead of dropping off as you move outward. The reason for this strange behaviour, scientists now believe, is dark matter. There must be an enormous halo of invisible, unknown mass surrounding the galaxy, creating additional gravity that affects the motion of stars. Without this dark matter holding everything together with its gravity, the galaxy simply would not rotate the way it does. In fact, without dark matter, the Milky Way would likely have flown apart and disintegrated long ago. The galaxy turns through space like a solid wheel rather than like a solar system, not because we fully understand why, but because something unseen and mysterious is holding it all in place with invisible hands. Fact 26. The Milky Way contains enormous molecular clouds scattered throughout its spiral arms and disk. These clouds are vast regions of extremely cold gas, composed mostly of hydrogen molecules with traces of dust mixed in. Some of these clouds are absolutely gigantic, spanning hundreds of light years from one side to the other. That means it would take hundreds of years travelling at the speed of light just to cross from one edge to the other. Within their cold, dense interiors, which can be just a few degrees above absolute zero temperature, gravity slowly begins to gather and concentrate material into clumps. These clumps continue growing denser and denser until they eventually collapse inwards and form brand new stars and planetary systems. Some molecular clouds are so large and so cold that they completely absorb all visible light that tries to pass through them. When you look at these regions with a regular optical telescope, they appear as black patches against the starry background, like holes torn in the fabric of the sky. But they are not empty voids. Instead, they are the galaxy's wombs, quiet and hidden places where the future is being shaped in silence, tucked away within dark curtains made of shadow and frozen gas. Fact 27. 7. Supernova explosions stir and mix the galaxy like enormous storms. When truly massive stars reach the absolute end of their lives after burning through all their nuclear fuel, they do not simply fade away quietly. Instead, they explode in catastrophic events called supernovae. These explosions are so incredibly powerful that a single supernova can briefly outshine an entire galaxy containing billions of stars. But supernovae do not just destroy, they also create and renew. The shock waves from these explosions ripple outward through the interstellar medium, the thin soup of gas and dust between stars. These violent shock waves compress nearby clouds of gas, squeezing them and triggering brand new waves of star formation in regions that might otherwise have remained dark and dormant. Supernovae also enrich and fertilize the surrounding space by scattering heavy elements like iron, gold, carbon, and oxygen. These elements were forged deep in the core of the dying star during its final moments. In this way, supernova explosions act like powerful storms within the galactic ecosystem. They stir things up, they spread nutrients, and they reshape everything around them. They are the galaxy's moments of necessary chaos, destructive and radiant and violent, but also absolutely essential for the continued cycle of death and rebirth. Fact 28. Interstellar dust hides vast regions where stars are actively forming. The Milky Way is absolutely full of light that we simply cannot see with our eyes or with regular optical telescopes. Interstellar dust, made up of microscopic grains of carbon, silicon, and ice, weaves its way through this galaxy in enormous clouds and delicate tendrils. When viewed in regular visible light, this dust completely obscures and blocks our view of what lies beyond. It blots out entire star systems and hides massive nebulae from sight. But the truth is that behind this dark veil, star formation continues without pause. Infrared telescopes, which can detect heat rather than visible light, have the special ability to peer through the dust and reveal what is hidden. When astronomers point infrared instruments at these apparently dark regions, they discover glittering nurseries absolutely filled with newborn suns that are still wrapped in their birth cocoons. What looks at first like empty darkness or blank space is actually often the beginning of something extraordinarily bright. The dust, though it hides and conceals, is actually part of the creative process. It absorbs energy from nearby stars, it helps clouds of gas cool down so gravity can compress them, and it shields the delicate early stages of stellar birth from harsh radiation. What seems like emptiness and shadow is frequently the beginning of new light waiting to emerge. Fact 29. There are enormous clouds of gas drifting through the galaxy that remain completely dark and starless. Not every single cloud of gas in the Milky Way eventually collapses and ignites into stars. Across the galaxy, astronomers have discovered massive cold clouds that seem like they should be perfect candidates for star formation, and yet they remain stubbornly dark and dormant, with no signs of active star birth happening inside them. Some of these clouds are simply too spread out and diffuse. The gas is not concentrated enough for gravity to gather it together effectively. Other clouds may be held up and stabilized by magnetic fields threading through them, or by internal turbulence and chaotic motion that prevents them from settling down and collapsing. These starless clouds float quietly through the galaxy like silent possibilities, rich in molecular hydrogen but completely untouched by the fire of nuclear fusion. They may eventually ignite and form stars one day in the distant future when conditions change, or they may drift aimlessly until they are torn apart by external forces like supernova shock waves or gravitational encounters with other structures. When that happens, their gas gets recycled and redistributed into other regions of the galaxy, where it might finally participate in star formation. In these patient waiting clouds, the galaxy seems to be holding its breath, waiting for just the right nudge or trigger to spark something entirely new. Fact 30. The Milky Way recycles matter across many generations of stars. Individual stars are not permanent fixtures in the universe. They have life cycles. They are born and they live for millions or billions of years burning their nuclear fuel, and eventually they die. But when stars die, they do not simply vanish. Instead, they return their material back to the galaxy through very source processes. Massive stars explode as supernovae, violently spreading their contents across light years of space. Smaller and medium-sized stars like our Sun swell up into red giants and gently shed their outer layers, creating beautiful structures called planetary nebulae that drift outward into the surrounding space. This enriched material, now containing heavy elements that were created inside the stars through nuclear fusion, joins the interstellar medium. There it slowly cools down, mixes with other gas and dust, condenses into new clouds, and eventually forms the next generation of stars and planetary systems. Every single atom in your body, the iron in your blood, the calcium in your bones, the oxygen you breathe, has passed through this cosmic cycle multiple times. These atoms were born inside ancient stars, scattered into space when those stars died, gathered together again into new structures, and eventually ended up incorporated into the Earth and into living creatures like you. The Milky Way is not a static stage where events simply play out. It is a vast engine of continuous renewal and transformation. The galaxy breathes slowly in time with the lives and deaths of its stars, endlessly making, unmaking, and beginning again in an eternal cycle. Fact 31. Metal-poor stars scattered through the galaxy's halo hold precious clues about the very early universe. In astronomy, when scientists talk about metals, they are not just referring to things like iron or gold. The term metal actually means any chemical element that is heavier than helium. The very earliest stars that formed in the universe, right after the Big Bang, had almost none of these heavier elements because previous generations of stars had not yet existed to create them through fusion and supernova explosions. Today, astronomers actively search for what they call metal-poor stars in the halo region of the Milky Way. These incredibly faint and ancient stars preserve the chemical conditions and composition of a time that is now long vanished. By carefully analysing the light from these stars and breaking it down into its spectrum of colours, scientists can determine exactly what elements they contain. Some of these metal-poor stars have less than 1/10,000th of the iron content found in our Sun. They are believed to be among the very first stars born after the earliest supernova explosions began to enrich the primordial gas with trace amounts of heavy elements. They formed during the period just after the Big Bang, before galaxies like ours had properly matured and taken their modern shapes. These stars are like fossils, but instead of being made of rock and bone, they are made of living light. They are ancient witnesses to the dawn of cosmic time. Factor 32. Many stars wander far from the places where they were originally born. The birthplace of a star does not necessarily determine where it will spend the rest of its existence. Over incredibly long periods of time, many stars gradually drift away from their natal clouds and star-forming regions. They get pushed and pulled by gravitational interactions with other stars and massive clouds. They respond to something called orbital resonance, which can slowly change their paths through the galaxy. They feel the gentle but persistent tug of the spiral density waves as they pass through the galaxy's arms. Some stars get ejected at surprisingly high speeds, flung across the disk or hurled up into the halo by close gravitational encounters. Other stars migrate more gradually and peacefully, slowly shifting their orbits either inward toward the galactic center or outward toward the edges over millions of years as they travel through the complex gravitational landscape of the galaxy. Even our own Sun is not located where it first formed 4.5 billion years ago. By tracing the paths and motions of stars backward through time using computer simulations, astronomers have revealed that the Milky Way is anything but static and unchanging. It is a galaxy that is constantly alive with movement, exchange, reshuffling, and quiet dislocation. Home for any particular star may only be a temporary situation, a brief pause in a much longer journey through space. Fact 33. The Milky Way may have its own galactic habitable zone, where conditions are best for life. Just as Earth orbits within what scientists call the habitable zone around the Sun, not too close where water would boil away and not too far where everything would freeze solid, the Milky Way itself may have a similar zone on a much larger scale. This galactic habitable zone is thought to exist in a broad ring somewhere between the dangerous chaotic inner core and the sparse metal-poor outer edges of the galaxy. The inner regions near the galactic center are full of intense radiation from densely packed stars, frequent supernova explosions, and extreme gravitational disturbances that could disrupt planetary systems and sterilize worlds. The outermost regions, on the other hand, contain mostly old metal-poor stars. Planets forming in these regions might struggle because there are not enough heavy elements like carbon, oxygen, silicon, and iron available to build rocky worlds and support complex chemistry. Somewhere in the middle zone, conditions become just right. Star density is moderate, so catastrophic events are less frequent. Heavy elements are abundant enough for rocky planets to form, and the environment is relatively stable over billions of years, giving life enough time to potentially emerge and evolve. Earth and our solar system happen to orbit comfortably within this favourable zone, one quiet location in a vast swirl where the conditions for life might not be unique to our planet alone. Fact 34. The spiral arms of the Milky Way are not fixed, permanent structures made of specific stars. This is a concept that surprises many people when they first learn about it. The beautiful spiral arms that give the galaxy its distinctive pinwheel appearance might seem like they must be solid features, grand sweeping lines carved permanently into the disk. but the reality is quite different. The arms are not made of particular stars that always stay in those locations. Instead, they are temporary patterns, density waves that slowly ripple through the galactic disk over time. These waves compress gas and dust as they move through space, and this compression triggers bursts of star formation that light up the arms with bright young stars. Individual stars drift into these density wave regions, shine brilliantly for a while as part of the visible arm structure, and then gradually drift back out again on the other side. Meanwhile, new stars are constantly forming behind them to take their place. The spiral structure itself rotates at a different speed than the stars do, like a traffic jam that moves along a highway, while individual cars enter the jam from behind and exit it up ahead. From far away, the pattern looks stable and permanent and well-defined. But from within the galaxy, from our perspective, it is actually a constantly shifting dance of matter and rhythm, held together not by physical bonds, but by the subtle forces of gravity acting over vast distances and enormous spans of time. Fact 35. The Milky Way hums and glows with many forms of invisible cosmic radiation. Beyond the narrow band of visible light that human eyes can detect, the galaxy shines and radiates with far more mysterious and energetic forms of radiation. Cosmic rays, which are high-energy particles mostly made of protons and atomic nuclei, constantly stream through space and pass directly through your body every single second of every day. These particles were launched long ago by exploding stars and other violent cosmic events, and they travel at nearly the speed of light. X-rays and gamma rays shimmer and flash from the vicinity of dying stars, from matter falling into black holes, and from the extremely hot gas found in supernova remnants. Radio waves drift outward from enormous gas clouds, from rapidly spinning neutron stars called pulsars, and from the cold breath of hydrogen gas that permeates the space between stars. These invisible forms of energy reveal aspects of the galaxy that visible light simply cannot show us. They expose violence, powerful magnetic fields, and ancient fires that are still flickering and burning within the very bones of the galactic structure. When you look up into the night sky with just your eyes, you are only seeing an extremely narrow slice of what the Milky Way truly is. Beneath and beyond the familiar stars, the galaxy hums softly and continuously in many colours, many frequencies and many wavelengths. It sings a hidden symphony in the darkness, a concert that requires special instruments to hear. Fact 36. There are two gigantic gamma-ray bubbles extending above and below the galactic core. Stretching tens of thousands of light-years upward above the galactic centre and downward below it are two vast ghostly lobes of extremely high-energy light. These structures are called the Fermi bubbles, named after the space telescope that discovered them relatively recently. They glow intensely in gamma rays, which are the most energetic form of light in the universe, but they are completely invisible to human eyes and to regular optical telescopes. Each bubble extends like an enormous balloon from the heart of the Milky Way, symmetric and striking in their appearance. Astronomers are not entirely certain what created these mysterious structures. One leading theory suggests they may be the remnants of a dramatic outburst that happened long ago, when the supermassive black hole at the galactic centre was more active than it is today. Perhaps millions of years ago, a huge amount of matter fell into the black hole all at once, creating jets of energy that blasted outward above and below the galactic plane. Another possibility is that these bubbles mark the signature of an intense period of star formation that once flared through the core region, with countless stars being born and dying in rapid succession. Either way, these gigantic structures drift silently above and below the galaxy, invisible to our eyes but unmistakable in gamma-ray light. They serve as reminders that the Milky Way has a dramatic and violent past that we cannot fully see, echoes of ancient cosmic events wrapped in radiation high above the familiar stars. Fact 37. Our solar system does not lie in one of the Milky Way's major spiral arms. When astronomers map out the large-scale structure of the galaxy, they identify several grand, sweeping spiral arms that contain most of the bright stars and active star-forming regions. These include arms with names like the Perseus arm and the Sagittarius arm, but our solar system is not located in any of these major features. Instead, we occupy a much smaller structure that astronomers call the Orion Spur, sometimes also known as the Orion Arm. This spur is essentially a relatively quiet lane of stars that sits nestled between the larger Sagittarius and Perseus arms. It is not specially dense with stars and is not particularly active in terms of ongoing star formation. But this apparently modest location may actually be quite fortunate for life on Earth. In the calm space between the galactic highways, massive supernovae are considerably rarer. Deadly radiation storms from dying stars occur less frequently. Gravitational disturbances that could disrupt the orbits of planets are less common. This relatively quiet corner of the galaxy may have provided Earth with the long periods of stability it needed for life to first emerge and then slowly evolve over billions of years into the complex biosphere we see today. From the outside looking in, the dramatic spiral arms of the galaxy seem bright and exciting. But here in our modest spur, tucked away from the main action, we found just enough peace and quiet for something as delicate and improbable as life to unfold. Fact 38. The Milky Way has a thick bar-shaped structure crossing through its centre. When astronomers observe the galactic core using infrared light, which can penetrate through the dense clouds of dust that obscure visible light, they can see past the obscuring material to reveal the true structure underneath. What they have discovered is that the very centre of the galaxy does not form a perfect circle or sphere. Instead, it contains a thick, elongated bar of densely packed stars that stretches across the middle like a glowing bridge or rod. This central bar is a common feature. Many spiral galaxies throughout the universe have similar bars running through their cores. These bars form naturally over billions of years when stars in the inner disk begin to drift inward and gradually pile up along a central axis due to gravitational instabilities and resonances. Once formed, the bar becomes a stable and long-lived structure. It rotates slowly as a coherent unit, and its powerful gravitational pull actively shapes the inner spiral arms, influencing their structure and behaviour. The bar also plays an important role in the galaxy's evolution by stirring up gas in the inner regions and funneling material gradually inward toward the supermassive black hole at the very centre. The bar is not merely a shape or a visual feature, it is a dynamic engine of activity, actively sculpting the galaxy's heart from within, driving gas flows and triggering star formation in specific patterns. Fact 39. The Milky Way is part of a larger structure called the local group. Our galaxy does not exist alone in an empty void. It belongs to a collection of more than 50 galaxies that are grouped together through their mutual gravitational attraction. This collection is called the local group. The two largest and most massive members of this group are the Milky Way and the Andromeda galaxy. Each of these giant spirals has its own family of smaller satellite galaxies orbiting around it like moons around a planet. Scattered throughout the local group are numerous smaller companions, including dwarf galaxies that are faint and contain relatively few stars, elliptical galaxies with no spiral structure, and some truly bizarre star-pore systems that seem to be made almost entirely of dark matter with just a sprinkling of visible stars. The entire local group spans more than 10 million light-years across space, and all of its member galaxies are bound together, not simply by physical proximity, but by the invisible threads of gravity. We are part of a cosmic family, widely spaced and loosely organized, but still fundamentally linked by shared motion and mutual gravitational pull acting across the vast emptiness between galaxies. Fact 40. The galaxies in the local group are gravitationally bound together and slowly falling toward each other. Despite the truly enormous distances separating the galaxies in the local group, ranging from millions to tens of millions of light-years, these galaxies are not simply drifting apart from each other. In fact, the opposite is true. Many of them are actually moving slowly toward one another through space, drawn together by their combined gravitational attraction. Gravity holds them in a kind of slow-motion cosmic ballet, gently curving their paths across millions of years of time. Some of the smallest dwarf galaxies orbit around the Milky Way and Andromeda, like tiny moons caught in the gravitational well of their much larger companions. These small galaxies loop around and around, sometimes falling inward and dissolving into long streams of stars. Other galaxies in the group drift more independently through space, but they remain gravitationally tethered to the overall structure. Over enormous spans of future time, this gravitational binding may cause the group to condense even further. Some galaxies may merge together and combine. Others may fade away as their stars scatter. This is not a static arrangement frozen in space. It is a gentle gathering of cosmic islands, a family being drawn slowly closer together by time, inertia, and the patient, inexorable reach of gravity working across the darkness. Fact 41. The disk of the Milky Way actually has two distinct components called the thin disk and the thick disk. When astronomers map out the three-dimensional structure of the galaxy in detail, they discover that what we think of as the flat galactic disk is not actually uniform throughout. The disk has layers, like a sandwich or a geological formation. The thin disk is where we and most nearby stars live. It is a wide, relatively flat plane filled with young stars, open star clusters, and active star-forming regions full of gas and dust. But above and below the thin disk, extending several thousand light-years in each direction, there exists another layer called the thick disk. This thick disk is older, puffier, and much more diffuse and spread out. Stars in the thick disk tend to be considerably older than those in the thin disk, and they contain fewer heavy elements in their atmospheres. They also move through space on orbits that are more tilted, more elliptical, and more randomized compared to the orderly motion of stars in the thin disk. This suggests that thick disk stars may have formed under very different conditions, perhaps during an earlier epoch of galactic history, or that they were stirred up and scattered by ancient gravitational disturbances, like past mergers with dwarf galaxies. The Milky Way's disk is not a simple uniform sheet of stars. It has texture, layers, and structure that have been shaped by billions of years of complex history. Fact 42. A vast magnetic field threads through the entire Milky Way galaxy. Though this field is completely invisible to human eyes and to most telescopes, the galaxy is laced with magnetism that stretches across the disk, rises up into the halo, and weaves through the interstellar medium in complex patterns. By earthly standards, this galactic magnetic field is actually quite weak. It is thousands of times weaker than the magnetic field you would feel from a simple refrigerator magnet. But because the field extends across such absolutely enormous distances, spanning tens of thousands of light years through space, it has profound effects on how the galaxy works and evolves. This magnetic field shapes how cosmic rays travel through space, bending their paths and trapping them within the galaxy for long periods. It influences how clouds of gas collapse and fragment when forming new stars. It controls how matter flows through the interstellar medium, creating channels and barriers. The field aligns itself with the spiral arm structures in some regions, while in other areas it forms giant arcs that rise high above the galactic plane and twist into loops that scientists still struggle to fully explain. Studying this invisible magnetic skeleton requires radio telescopes and very careful analysis of how the field affects other things we can observe. But its presence is absolutely unmistakable. The Milky Way does not just glow with light and shine with stars. It also breathes with magnetism, a subtle pulse running through its bones and structure. Fact 43. The space between stars is not empty, but is filled with invisible structures and activity. Most people imagine that the regions between the stars must be completely empty vacuum, but this is far from the truth. The interstellar medium, which is the technical name for all the matter that exists between star systems, is a thin blend of gas particles, dust grains, and plasma that weaves its way through the entire galaxy like a cosmic fog. To the naked eye looking up at the night sky, this medium is mostly invisible and undetectable. But when astronomers view it with specialized instruments like radio telescopes and infrared detectors, it reveals absolutely stunning complexity and structure. The interstellar medium forms delicate filaments that stretch across light years. It creates enormous bubbles blown out by stellar winds and supernova explosions. It contains shock waves racing outward from violent events. And it holds cold, dense clouds where new stars will eventually be born. Supernova explosions carve out vast hollow cavities in this medium, creating regions of extremely low density. Meanwhile, stellar winds from massive hot stars sculpt the gas into intricate shapes that ripple and flow across enormous distances. The temperature of this material can vary wildly from region to region. Some areas are incredibly cold, just a few degrees above absolute zero. Other regions have been heated to millions of degrees by shock waves and high-energy radiation. The space between stars is not a peaceful void or an empty stage. It is a shifting, dynamic web of matter and magnetism, the quiet fabric from which galaxies gradually evolve and from which life itself eventually begins its long journey. Fact 44. Every second of every day, countless high-energy particles called cosmic rays pass directly through your body. These cosmic rays are mostly protons and atomic nuclei that have been accelerated to incredibly high speeds, often approaching the speed of light itself. They were launched long ago by violent cosmic events, especially supernova explosions. These particles stream through space in all directions, bending and bouncing through the galaxy's magnetic fields, sometimes traveling for millions of years before finally reaching Earth. Most of the time, we do not notice them at all. They pass through us harmlessly, leaving no trace we can feel. But occasionally, cosmic rays collide with atoms in Earth's upper atmosphere, creating cascading showers of secondary particles that rain down toward the surface. These particles carry incredible amounts of information encoded in their paths and energies. They are evidence of ancient supernovae that exploded long before humans existed. They are traces of acceleration happening in distant corners of the galaxy. They are messages arriving from the violent, energetic hearts of dying stars. Even as you rest comfortably tonight and let your mind drift towards sleep, the galaxy continues to whisper its stories through your body in the form of these invisible, soundless rays of light and matter, arriving constantly from the darkness, connecting you physically to cosmic events happening light years away. Fact 45. The Milky Way galaxy is not perfectly symmetrical or balanced. Though many diagrams and artistic illustrations show the galaxy as a neat, evenly balanced spiral with arms that match on both sides, the reality is much more complex and irregular. The actual Milky Way is not perfectly balanced at all. Careful observations reveal that one side of the disk appears noticeably thicker than the other side. Some spiral arms are significantly brighter, longer, or more tightly curved than their counterparts. The warp in the outer disk, where the edges bend upward and downward, is distinctly lopsided rather than symmetric. Even simple star counts reveal that there are slightly different numbers of stars in different hemispheres of the galaxy. These various asymmetries and irregularities may have been caused by gravitational encounters with neighbouring dwarf galaxies, by past merger events that disturbed the structure, or by the lumpy, uneven influence of dark matter distributed throughout the galactic halo. These imperfections remind us that real galaxies, just like living organisms, carry visible traces of their complex histories written into their physical shapes. They have scars from ancient collisions, wrinkles from billions of years of gradual evolution, and quirks of uneven growth that give each galaxy its own unique character and depth. Perfect symmetry exists only in idealized models. The real universe is far messier and far more interesting. Fact 46. The oldest star that we know of in the entire Milky Way may be drifting through the galactic halo. High above the crowded galactic plane, orbiting slowly through the sparse halo region, astronomers have discovered an ancient star that may be nearly as old as the universe itself. This remarkable object contains almost no heavy elements whatsoever in its atmosphere, which is a clear signature of stars that were born extremely early in cosmic history, soon after the Big Bang and before many generations of supernovae had time to enrich the surrounding gas with metals. Based on careful analysis of its chemical composition, scientists estimate this star likely formed more than 13 billion years ago, long before the Milky Way had even taken its current spiral form. Despite its incredible age, it continues to burn quietly with a soft red glow, relatively low in mass but extraordinarily rich in historical information. This star is not simply another point of light in the sky. It is a living time capsule, a genuine relic from the universe's earliest dawn, still shining faintly after all these billions of years. By studying stars like this one, astronomers can peer back to an era when the cosmos was young and wild, when the first generation of stars was just beginning to light up the darkness, when galaxies were still assembling themselves from primordial clouds of gas. Fact 7. The inner regions of the Milky Way spin much faster than the outer regions. Near the galactic core, where matter is densely packed and gravitational forces are extremely strong, stars complete their orbits around the centre much more rapidly than stars living farther out in the suburbs. The enormous concentration of mass near the centre, including countless stars, thick clouds of gas and dust, and the 4 million solar mass black hole called Sagittarius A star, creates intense gravitational pull that causes nearby stars to sweep through very tight, very fast orbits. Some of these inner stars complete a full revolution around the galactic center in just a few million years. Meanwhile, out in the quieter neighborhoods where our sun resides, stars orbit much more slowly and leisurely, taking hundreds of millions of years to make the same journey. This dramatic difference in rotation speed between inner and outer regions creates interesting effects. It causes the disk to twist and stretch. It helps form and maintain the spiral arm patterns, and it keeps the galaxy from behaving like a single solid, rigid structure. Instead, the Milky Way moves through space more like a great spinning wheel where the hub turns much faster than the rim, creating shear forces and dynamic patterns that constantly reshape the galaxy's appearance over time. Fact 48. The spiral arms of the Milky Way are shaped and maintained by travelling density waves. This concept is one of the most elegant and beautiful ideas in galactic astronomy. The spiral arms that give our galaxy its characteristic pinwheel appearance are not permanent features made of specific stars that remain locked in those positions forever. Instead, they are temporary patterns created by waves of higher density that move slowly through the galactic disk, like ripples spreading across the surface of a pond. As enormous clouds of gas and dust pass through these density wave regions, they experience compression from the increased gravitational forces. This compression squeezes the clouds, causing them to collapse more rapidly and trigger intense bursts of star formation. The newly formed stars are bright, hot and blue, and they light up the spiral arms with brilliant luminosity. But these stars do not stay in the arms permanently. They eventually drift out of the high-density region and continue on their individual orbits around the galaxy, while behind them new stars are constantly forming to take their place. The density wave itself moves at a different speed than the individual stars, creating a self-sustaining pattern. From a great distance, the arms appear still and unchanging, but from within the galaxy, they are actually a dynamic dance of matter and rhythm, an ever-changing pattern shaped by the invisible hand of gravity acting across vast distances and enormous stretches of time. Fact 49. New stars are born from the coldest and darkest regions of the galaxy. It might seem paradoxical at first, but the birthplaces of stars are some of the coldest locations in the entire Milky Way. Star formation begins in complete silence and darkness within massive clouds of molecular hydrogen gas. These clouds drift through space at temperatures of just a few degrees above absolute zero, which is the coldest temperature theoretically possible in the universe. Some of these stellar nurseries are hundreds of light years wide, containing enough material to create thousands or even millions of new stars. Within the dark, frigid depths of these clouds, gravity very slowly begins to take control. Small regions of slightly higher density start to attract surrounding material, growing denser and denser over time. As more and more gas falls inward toward these centers, the cloud fragments into smaller clumps. Each clump continues collapsing under its own increasing weight. As the gas falls inward, it gradually heats up from the compression, begins to spin faster due to conservation of angular momentum, and flattens out into a rotating disk shape. At the very center, a hot, dense core called a protostar slowly forms. Over hundreds of thousands or millions of years, the temperature and pressure in this central region grow higher and higher, until finally nuclear fusion ignites deep in the core and a genuine star is born. From the coldest shadows and the darkest corners of the galaxy come the brightest lights in the cosmos, spun gently into existence by nothing more than the patient, inexorable force of gravity. Fact 50. Star clusters that are born together can eventually dissolve and scatter across the galactic disk. Many stars do not form alone in isolation, but instead are born in groups. These stellar siblings all condense from the same giant collapsing gas cloud at roughly the same time, creating what astronomers call star clusters. These clusters can contain anywhere from a few dozen to many thousands of stars, all bound together initially by their mutual gravitational attraction. The stars in a young cluster drift through space together like a family, remaining relatively close to each other for millions or sometimes even billions of years. But over extremely long periods of time, these clusters gradually begin to come apart and scatter. There are several forces that work to pull clusters apart. Tidal forces from the overall mass of the Milky Way galaxy tug at the cluster from different directions, slowly stretching it out. Close gravitational encounters between stars within the cluster can give some members enough energy to escape entirely, and interactions with giant molecular clouds that the cluster passes through can strip away outlying members. Stars gradually peel away from the group one by one, drifting off on their own paths through the galaxy, until eventually the cluster fades completely into the general background starfield. Even our own Sun was likely born in a stellar cluster billions of years ago. Fact 51. Among the rarest and most valuable objects in the entire Milky Way are what scientists call hypermetal-poor stars. These are stars whose outer layers contain almost no elements heavier than helium whatsoever. Some of these remarkable objects contain less than 1/10,000th the amount of iron found in our Sun. Astronomers believe these stars are among the very first born after the earliest supernova explosions in the universe, carrying only faint traces of chemical enrichment from a cosmos that was still forming and organizing itself. They are incredibly ancient, incredibly pure in composition, and scattered throughout the halo region like distant lanterns left over from the dawn of time. Each one represents a kind of astronomical treasure, a glowing gravity-bound signature from an epoch that has been almost completely forgotten. By studying these pristine stars, scientists can learn about conditions that existed more than 13 billion years ago, when the universe was still young, and the first generation of massive stars was just beginning to create the heavier elements through fusion and explosive death. Fact 52. Planetary systems form naturally throughout the Milky Way as a normal consequence of how stars are born. Planets are not rare or unusual features of the cosmos. They are actually a natural and expected outcome of the star formation process. When a new star ignites at the center of a collapsing gas cloud, it does not consume all the available material. A rotating disk of leftover gas and dust inevitably surrounds the young star, and within this disk, small particles gradually stick together through collisions. These particles gather more and more mass over time, growing from dust grains into pebbles, from pebbles into boulders, from boulders into mountain-sized objects, and eventually into full-grown worlds. Across the entire Milky Way, planetary systems appear to be extremely common. Some systems are vast and spread out, containing enormous gas giant planets and frozen moons orbiting far from their parent star. Other systems are compact and crowded, with rocky planets hugging close to dim red dwarf stars. Some planetary systems may look and behave much like our own solar system, while others defy our expectations entirely, with bizarre configurations we never imagined before discovering them. The galaxy is not merely full of stars shining in the darkness. It is full of complete solar systems, entire families of worlds orbiting their suns, each one with its own unique arrangement, its own specific balance of gravity and motion, and potentially its own story waiting to be discovered. Fact 53. Earth and our solar system happen to orbit near something called the co-rotation radius of the Milky Way. This is a special location in the galaxy where something interesting happens with motion and speed. In the Milky Way, the spiral arm patterns rotate at a different speed than individual stars do. The arms move like a wave or pattern rather than like a solid object. But there is a specific distance from the galactic center called the co-rotation radius, where the average speed of stars orbiting matches almost exactly the rotation speed of the spiral arm pattern itself. Our Sun orbits very close to this special boundary region. This fortunate match in orbital speed may actually help protect us from certain dangers. It means we avoid frequently crossing through the spiral arms, which are denser regions full of newly forming stars, higher concentrations of matter, more frequent supernova explosions, and stronger gravitational disturbances that could potentially disrupt planetary orbits. We live, quite possibly by pure chance, in a more stable and calmer neighborhood of the galaxy. We are shielded from harm not by physical walls or barriers, but by a subtle resonance in motion, a cosmic coincidence that keeps us safely between the arms. Fact 54. As it orbits around the Milky Way, our Sun does not follow a perfectly flat level path through space. Instead, the Sun moves in a gentle wave pattern, drifting gradually upward above the galactic plane and then slowly sinking back downward below it, like a cork bobbing up and down in very slow motion on the surface of an ocean. This vertical oscillation takes tens of millions of years to complete each full cycle. The sun rises and falls through the disk as it travels around the galaxy, sometimes passing through regions of higher stellar density, and sometimes cruising through emptier spaces. This bobbing motion is caused by the gravitational tug of all the mass in the galactic disk pulling and releasing the solar system as it moves along its orbital path. Some researchers have even speculated, though the evidence remains uncertain, that this vertical motion through different environments might somehow influence long-term cycles of climate change or extinction events on Earth, as we pass through regions with different amounts of cosmic radiation or gravitational disturbance. Regardless of whether that particular idea is correct, the oscillation is a reminder that even on its steady journey around the centre, the Sun is not simply gliding smoothly along. It is gently swaying up and down through the thickness of the galactic disk. Fact 55. We still do not know what dark matter actually is, but we are absolutely certain that it exists. Dark matter makes up the majority of the Milky Way's total mass, yet it has never been observed directly by any instrument or telescope. It does not give off light or absorb light. It does not emit any form of radiation that we can detect, whether radio waves, infrared, visible light, ultraviolet, X-rays or gamma rays. It passes through ordinary matter as if it were not even there, like a ghost moving through walls. But despite being completely invisible and undetectable except through one crucial property, its gravitational effects are absolutely unmistakable and undeniable. Dark matter holds the galaxy together through its gravity. It explains why stars in the outer regions orbit faster than they should, based on visible matter alone. It shapes the formation of large-scale cosmic structures throughout the universe. Without dark matter providing gravitational glue, the Milky Way would simply fly apart and cease to exist as a coherent galaxy. Astronomers detect dark matter not by seeing it directly, but by carefully watching how it moves and influences other things that we can see. It is the hidden scaffolding of the galaxy, invisible and silent and mysterious, yet absolutely essential. Dark matter remains one of the deepest and most frustrating mysteries in all of modern science. Fact 56. There is actually more total mass located outside the bright galactic disk than exists within it. Most of the Milky Way's visible stars, the ones we can see with telescopes and that create the beautiful spiral pattern, lie within the relatively flat and luminous disk structure. But the majority of the galaxy's actual mass resides somewhere else entirely. The galaxy is surrounded and enveloped by an absolutely enormous dark matter halo that extends far beyond the furthest visible stars. This invisible halo holds everything together through its gravity, and it outweighs the visible disk by a very large margin. The halo is also populated sparsely with some visible matter, including ancient stars and globular clusters, but these represent only a tiny fraction of the total mass present. When we think about the Milky Way and try to picture it in our minds, we naturally imagine the spiral arms and the flat, starry plane that we can see in photographs. But that glowing disk is really only the surface, only the visible tip of something much larger and more massive. The true bulk of the galaxy, the mass that actually defines its gravitational reach and its motion through space, is mostly hidden from view, surrounding everything like an invisible shroud that we can sense only through its effects on visible matter. Fact 57. The supermassive black hole at the core of our galaxy may have once flared dramatically as a quasar. Today, when astronomers observe the heart of the Milky Way, it appears relatively quiet and dormant. But there is growing evidence suggesting that in the distant past, perhaps just a few million years ago, which is very recent in cosmic terms, the centre was dramatically more active and violent. The presence of huge structures like the Fermi bubbles, those enormous gamma-ray balloons extending above and below the galactic plane, along with traces of high-energy light reflected and echoed in surrounding gas clouds, suggest that the supermassive black hole at our centre may have once burned as a quasar. Quasars are among the most brilliant and energetic objects in the entire universe, blazing with the light of 1 trillion suns, powered by massive amounts of matter spiralling into a black hole and heating to incredible temperatures before disappearing forever. They can outshine entire galaxies. If the Milky Way once went through a quasar phase, it would have looked dramatically different from how it appears today. Instead of being a relatively calm spiral, it would have been wrapped around a blinding, violent heart of light and radiation. That active period has now passed and ended, but the echoes and remnants of that ancient fire still remain scattered through the galactic structure. Fact 58. The structure and appearance of the Milky Way changes slowly over billions of years. Galaxies may look timeless and eternal in photographs, frozen in perfect spiral forms, but the reality is that they are constantly evolving and transforming. The spiral arms gradually shift their positions. Central bars can form, strengthen, weaken, or potentially dissolve over time. Gas flows steadily inward from the outer regions and outward from star-forming areas. New stars are born while old stars die, continuously changing the overall population and its properties. Even the physical shape of the Milky Way's disk, with its warps and ripples and lopsided features, is very slowly changing and adjusting in response to external influences. Encounters with smaller dwarf galaxies can bend or twist the structure. The lumpy distribution of dark matter throughout the halo exerts subtle but persistent forces. Over billions of years, the galaxy's silhouette and form shift like a drifting cloud, never quite the same from one epoch to the next. The Milky Way that exists today is not identical to the galaxy that the dinosaurs saw when they looked up at the night sky. And the galaxy that our distant descendants might know, billions of years in the future, could be significantly larger, differently shaped, or fundamentally transformed. The beauty of galaxies lies not in permanence or stability, but in their nature as slowly evolving systems engaged in constant quiet transformation. Fact. 59. Gravitational waves ripple through the Milky Way constantly from distant cosmic collisions. All across the universe, massive objects collide and merge in violent encounters. Black holes spiral together and crash, neutron stars smash into each other. Entire galaxies merge and combine. These incredibly energetic events send out gravitational waves, which are actual ripples and distortions in the fabric of space-time itself. Though these waves become very faint as they spread outward across cosmic distances, some of them pass directly through the Milky Way galaxy, subtly distorting space itself by tiny, almost immeasurably small amounts as they travel at the speed of light. These waves are incredibly difficult to detect because the distortions they create are so fantastically small. But observatories like LIGO and Virgo have successfully captured signals from several dramatic merger events in recent years. New experiments now aim to detect what scientists call the gravitational wave background, a faint humming signal created by countless merger events throughout cosmic history, all combining together. Even right now, as you rest and let your thoughts drift, space itself is gently shifting and flexing around you. The distortions are far too small to feel or notice, but they tell us that somewhere far away across the universe massive objects are colliding, and the news of those collisions travels to us encoded in the shape of space itself. Fact 60. Some stars move through the galaxy on highly elongated and tilted orbital paths. Not all stars travel in neat circular orbits around the galactic center, like traffic moving smoothly on a highway. Some stars follow very different paths, moving on long-stretched ellipses that carry them on dramatic journeys. Their orbits loop high above the galactic disk and plunge far below it, tilted at unusual angles compared to the main plane where most stars live. These stars with strange inclined orbits likely come from different origins than the majority of stars in the disk. They are often relics of dwarf galaxies that were swallowed by the Milky Way billions of years ago during ancient merger events. Or they may be survivors of powerful gravitational encounters that flung them onto chaotic paths. Their unusual motions through space serve as clues and evidence, three-dimensional maps that help astronomers reconstruct the invisible architecture of the galaxy's mass distribution and piece together its complex, violent past. These stars drift through space like messengers from disrupted systems, traveling on tilted, stretched orbits, but still gravitationally bound to the larger whole, still part of the galaxy despite their unconventional paths. Factor 61. The Milky Way constantly emits ghostly particles called neutrinos that we can barely detect. Every single second, trillions upon trillions of neutrinos pass directly through your body, racing through you at nearly the speed of light and continuing onward without leaving any trace. These ghostly particles are produced constantly in nuclear reactions happening inside stars, especially in the core of our Sun. They are created during supernova explosions, and they are generated when cosmic rays strike atoms in space and in Earth's atmosphere. The entire Milky Way is absolutely bathed in neutrinos flowing in every direction. Yet these particles are so incredibly light and so unreactive with ordinary matter that they slip through almost everything without interacting at all, as if matter were not even there. Special observatories buried deep underground or placed under thick Antarctic ice try to catch just a few of these elusive particles. When a neutrino very rarely does interact with an atom, it can create a brief flash of light that sensitive detectors can observe. Neutrinos carry important information from places we cannot see with regular telescopes. They bring data directly from the cores of stars where light cannot escape. They carry news from collapsing stellar cores during supernova events. They tell us about the galaxy's unseen energy production and hidden processes. They are whispers from cosmic fires, passing through everything constantly. Fact 62. Interstellar space is not calm or smooth, but is actually a turbulent, chaotic environment. Between the stars, space is definitely not the peaceful, empty void that most people imagine. The interstellar medium, that thin soup of gas and dust floating between star systems, is constantly being stirred and mixed by powerful forces. Shockwaves from supernova explosions race outward at thousands of kilometers per second. Magnetic fields thread through the gas in complex, twisted patterns. The motion of stars creates gravitational disturbances. All of these effects combine to create a kind of turbulence on enormous scales, like a slow-motion ocean swirling and churning through the galactic disk. Temperature in this medium varies wildly from place to place. Some regions are extremely cold, hovering just barely above absolute zero temperature. Other areas have been heated to millions of degrees by shockwaves and intense radiation. Flows of material collide with each other, mix together, and fragment into smaller structures. Clouds stretch out, fold over themselves, and tumble chaotically through space. On large scales, this creates an environment that looks calm and orderly from far away, but is actually restless and dynamic up close. Star formation, the flow of cosmic rays, and even the overall evolution of galaxies are all strongly affected by this turbulent, stirred-up interstellar sea. What appears from a distance to be calm starlight and empty darkness is actually, when examined closely, a complex and ever-changing fabric shaped by the invisible winds and ancient energy still flowing through the galaxy. Fact 63. The galactic halo may contain billions of rogue planets drifting alone through the darkness. Planets are not always permanently attached to stars in stable solar systems. Some worlds form normally around stars, but are later ejected and flung away from their home systems by gravitational interactions. Other planets may possibly form independently, never having had a parent star at all. These orphaned worlds are called rogue planets, and they drift alone through the galaxy, cold and dark and completely isolated. Without any nearby star to warm them or light them up, they are incredibly difficult to detect and observe. But statistical studies and theoretical models suggest that there may be billions of these lonely worlds scattered throughout the Milky Way, perhaps even more rogue planets than there are stars. Some of these wanderers may even drift through the sparse outer halo region, far from the crowded disk where most stars reside. Without light or external warmth, these planets float unseen through space, warmed only slightly by whatever internal heat remains from their formation or from radioactive decay in their cores. They are orphans of the galaxy, planetary drifters following long, lonely paths through the darkness between stars, invisible travelers in the cosmic night. Fact 64. Magnetic fields actively shape and control the flow of cosmic dust throughout the galaxy. Interstellar dust, those microscopic grains of carbon and silicon floating between stars, does not move through space controlled only by gravity. It also responds strongly to the galaxy's magnetic field. These invisible magnetic forces thread through the Milky Way like currents in an ocean, and they guide the motion of electrically charged particles and influence how dust grains align themselves in space. In some regions, dust grains spin rapidly, emitting faint microwave light as they rotate. In other areas, the grains align themselves with the direction of magnetic field lines, and this alignment affects how they polarize the starlight passing through them. Understanding these magnetic effects helps astronomers trace out the structure of the galaxy's magnetic field, which is otherwise invisible. It also helps scientists remove the confusing effects of galactic magnetism from their observations of the cosmic microwave background, the ancient light left over from the Big Bang. Interstellar dust is not passive material that simply drifts wherever gravity takes it. Instead, it dances to a magnetic rhythm, responding to invisible forces and falling into hidden patterns throughout the dark spaces between stars. Fact 65. Some stars in the Milky Way are enriched with gold, platinum, and other heavy elements created in neutron-star collisions. When two neutron stars, the incredibly dense cores left behind after massive stars, explode, spiral together, and finally collide, they create one of the most violent and energetic events that can happen anywhere in the universe. This catastrophic merger is called a kilonova. During this brief blinding explosion, which lasts only seconds or minutes, enormous quantities of extremely heavy elements get forged and created. Gold, platinum, uranium, and many other elements heavier than iron are produced in abundance during these rare collisions. These precious materials are then cast outward into space at tremendous speeds, mixing with the surrounding gas and dust. Eventually, this enriched material gets incorporated into new generations of stars and planetary systems as they form. Some stars scattered throughout the Milky Way carry clear chemical fingerprints showing they contain unusually high amounts of these rare heavy elements. This tells astronomers that material from ancient neutron star collisions was present in the gas clouds from which these stars formed. They are not simply bright balls of glowing gas. They are also record keepers and witnesses of ancient cataclysmic events, burning with the physical residue of stellar catastrophes that happened long ago, carrying within their atmospheres the products of cosmic alchemy. Fact. The Milky Way may have a hidden bar structure within its central bar. At the heart of the galaxy, as we have learned, there is a prominent bar-shaped structure, an elongated concentration of stars that stretches across the central bulge. But deep within that primary bar, astronomers have found hints and suggestions of yet another smaller bar, tilted at a different angle and rotating independently on its own axis. This inner structure is incredibly difficult to see directly because it is heavily obscured by the thick clouds of dust and it is very far away from us. But its gravitational influence shows up in the patterns of motion of nearby stars and gas clouds. Nested bars like this may help explain how material gets funneled gradually inward from the outer galaxy toward the supermassive black hole at the very center. Each bar creates gravitational torques that transfer angular momentum and allow gas to fall slowly inward. The center of the Milky Way is not one simple geometric shape. It is a complex, layered, shifting labyrinth of light and motion, with structures nested inside other structures, each one playing a role in how matter flows and how the galaxy evolves. Fact. 67. Fresh gas continuously flows into the Milky Way from the cosmic web beyond. The Milky Way is not a closed or isolated system sealed off from its surroundings. It actively draws in new material from the intergalactic medium, from the vast network of gas filaments that connect galaxies throughout the universe in what astronomers call the cosmic web. Long, tenuous streams of gas flow inward along these filaments, providing fresh raw material for future star formation and replenishing what the galaxy gradually loses over time through various processes. Some of this gas arrives as cold filaments, slipping quietly into the outer disk without creating much disturbance. Other streams fall inward in hotter forms, shock-heated to high temperatures, lighting up briefly in ultraviolet or X-ray wavelengths as they crash into the existing gas surrounding the galaxy. These invisible rivers of matter help sustain the galaxy's ongoing growth and continued evolution over billions of years. They link the Milky Way to the larger universe beyond its visible boundaries. Even now, at this very moment, the galaxy is slowly drinking from distant reservoirs of primordial gas, nourished by threads of matter that were spun out across space during the early formation of cosmic structure billions of years ago. Fact. 68. Hot gas bubbles form tall chimneys that vent energy out of the galactic disk. When large clusters of massive stars all go supernova within a relatively small region and short time period, they create enormous cavities and hollow regions in the interstellar medium. These individual bubbles can merge and join together, forming what astronomers call superbubbles. These are vast pockets of extremely hot, low-density gas that can punch completely through the thickness of the galactic disk and vent upward into the halo region above. The result looks like a kind of chimney or exhaust vent, a channel through which energy, gas, and magnetic fields can escape from the crowded plane of the galaxy and flow out into the more empty halo. These galactic chimneys help regulate the pressure and conditions within the interstellar medium. They redistribute heavy elements created in stars throughout a larger volume of space, and they help shape the structure of the halo itself. In this way, the galaxy does not just breathe and circulate within its disk. It also exhales through these towering columns, carrying energy and material up and out into the surrounding darkness, connected vertically as well as horizontally. Fact 69. The Milky Way shines brightly in X-ray wavelengths from collapsed stellar remnants and black holes. Though the galaxy appears relatively calm when viewed in normal visible light, painting a serene picture of a spiral dotted with stars, it tells a very different story when observed in high-energy X-ray light. X-rays pour forth from the galactic core, where the supermassive black hole occasionally swallows material. They stream from collapsed stellar remnants like white dwarf stars and neutron stars that exist in binary systems and pull matter away from their companion stars. As this stolen gas spirals inward, it heats to millions of degrees and emits intense X-ray radiation. Hot gas in the halo also produces fainter but widespread X-ray emission, revealing the galaxy's larger skeletal structure and the consequences of ancient energetic events. We cannot perceive this high-energy light with human eyes, which evolved to see only a narrow band of wavelengths, but space telescopes like Chandra and XMM Newton reveal a completely different portrait of our home. Not a tranquil, peaceful spiral, but a realm filled with extreme temperatures, violent, compact objects feeding on their neighbours, and hidden sources of intense radiation scattered throughout the structure. Fact 70. Pulsars scattered throughout the galaxy act as incredibly precise cosmic clocks. When a massive star collapses and dies in a supernova explosion, it may leave behind an extremely dense remnant called a neutron star. Some of these neutron stars spin extraordinarily rapidly, rotating many times per second, with beams of radiation sweeping across space from their magnetic poles like lighthouse beams cutting through fog. These rapidly rotating neutron stars are called pulsars, and some rotate hundreds of times every single second, while remaining astonishingly precise in their timing. They are so consistent and regular in their rotation that astronomers use them as cosmic timekeepers. By carefully tracking the arrival times of pulsar signals, scientists can measure distances across space, test fundamental theories of gravity in extreme conditions, and even search for gravitational waves passing through the galaxy by detecting tiny timing variations. Across the Milky Way, these pulsars blink quietly and steadily, remnants of violent stellar death that have been transformed into beacons of remarkable order. They keep time not for minutes or hours or days, but for entire cosmic epochs, ticking away steadily in the silence between stars, helping us measure and understand the universe around us. Fact 71. Radio waves allow astronomers to map hidden structures throughout the galaxy. Much of the Milky Way remains completely invisible when observed in regular optical light, because of intervening dust, extreme distances, or simply because many objects do not emit visible light. But radio waves, which have much longer wavelengths than visible light, possess the special ability to slip through these barriers and reveal what would otherwise remain hidden. Radio telescopes trace cold hydrogen gas spread throughout the galaxy. They outline the shape and structure of magnetic fields. They highlight emissions from pulsars spinning in the darkness. They detect signals from supernova remnants and even from distant quasars shining beyond the galaxy. Using carefully coordinated arrays of radio telescopes working together, astronomers have successfully mapped the spiral arms of the Milky Way, measured the warped shape of the outer disk, and discovered active star-forming regions completely cloaked in dust. Where visible light gets blocked and absorbed, radio waves pass through freely. The galaxy speaks constantly in wavelengths and frequencies that human ears cannot hear and human eyes cannot see, but modern science has learned to translate these invisible signals into maps of shape and shadow, revealing the hidden architecture of our cosmic home. Fact 72. Our Sun was almost certainly born inside a stellar cluster alongside hundreds or thousands of sibling stars. Stars very rarely form in complete isolation. They are usually born in groups, entire clusters of stellar siblings that all condense from the same collapsing giant molecular cloud at roughly the same time. Our Sun was almost certainly one of these cluster members billions of years ago. Long ago, during the Sun's birth, it likely shared space with hundreds or perhaps even thousands of other newborn stars, all formed from the same cloud of enriched gas and dust, all igniting their nuclear fires about the same time. Over the billions of years since that distant birth, gravitational forces have done their slow work. The original cluster, whatever it looked like, has long since scattered and dissolved. Passing encounters with other stars and giant gas clouds gradually pulled the cluster apart. The Sun's siblings have wandered far away, flung into vastly different orbits, carrying within them tiny fragments of our shared past and origin. Most have dimmed with distance, many are now lost forever among the countless stars filling the sky, their family connection to our Sun completely erased by time and the vastness of space. Fact 73. Astronomers are actively searching for the Sun's lost sibling stars scattered across the galaxy. Though the Sun's original birth cluster dissolved billions of years ago, scientists have not given up hope of finding some of its ancient siblings. Using vast surveys like the Gaia spacecraft mission and detailed spectroscopic databases that analyze the chemical composition of millions of stars, researchers are searching for stars that share the Sun's age, motion through space, and unique chemical fingerprint. A few promising candidates have already emerged from this search. These are stars that may have formed from exactly the same enriched gas cloud that created our solar system. If these candidates can be confirmed as genuine siblings, they could reveal fascinating details about the specific conditions and environment in which the Sun and Earth were born 4.5 billion years ago. Our place in the galaxy turns out not to be entirely solitary after all. Somewhere out there among the hundreds of billions of stars filling the Milky Way, some of the Sun's ancient relatives may still shine, carrying within them pieces of the same story, born from the same cosmic cradle in the distant past. Fact 74. The flat disk of the Milky Way wobbles gently as it spins through space. The galactic disk is not perfectly flat and rigid like a dinner plate. Instead, it wobbles visibly, rippling gently like a spinning plate that has been nudged slightly off balance. This warp becomes most obvious and pronounced in the outer regions of the galaxy, where one edge of the disk bends noticeably upward while the opposite edge curves downward. The wobble may be caused by several different factors working together. The gravitational influence of nearby dwarf galaxies tugging on the edges of the disk could be partly responsible. Interactions with lumpy distributions of dark matter might also play a role, or internal asymmetries within the galaxy itself could create the effect. Whatever the cause, this wobble rotates slowly over time, like a vast wave moving through the population of stars. From our position on Earth, embedded deep within the structure, we do not feel or notice this motion. But from far away, from an external perspective, the Milky Way would not appear as a pristine, perfectly flat spiral. It would look like a breathing, gently undulating sheet of stars, curving and flexing as it turns through the darkness of space. Fact 75. Galactic tides can slowly distort and eventually destroy star clusters and satellite galaxies. Just as the moon's gravity creates ocean tides on Earth by pulling more strongly on the near side than the far side, the immense concentrated mass of the Milky Way exerts similar tidal forces on everything that orbits within or near it. Star clusters feel the galaxy's uneven gravitational pull across their extent. Small satellite galaxies experience these same stretching forces. Over extremely long periods of time measured in hundreds of millions or billions of years, these persistent tides can slowly stretch and distort these objects, gradually drawing out long stellar streams as stars get peeled away from the main body. Many of the faint arcs of stars that have been mapped across the sky surrounding our galaxy are direct evidence of such encounters. They are clusters actively in the process of being unraveled. They are small galaxies slowly being torn apart strand by strand. The Milky Way does not break these structures suddenly or violently in single catastrophic events. Instead, it dismantles them with enormous patience, pulling them apart gradually, strand by delicate strand, over millions and millions of years, until nothing remains but scattered streams of stars marking where smaller systems once existed. Fact 76. Scientists still cannot measure the exact mass of the Milky Way with complete precision. You might think that astronomers would know the weight of our own home galaxy with certainty, but measuring it accurately turns out to be remarkably challenging. Visible stars and gas clouds make up only a small portion of the total. The vast majority of mass lies hidden in the dark matter halo, which cannot be observed directly. Estimates vary considerably depending on which method scientists use. Some calculations suggest a total mass close to 1 trillion times that of our Sun. Other approaches place the figure much higher. The uncertainty comes from trying to measure how quickly stars orbit at enormous distances from the centre, a difficult task clouded by limited data and the overwhelming influence of invisible matter. The Milky Way is our cosmic home, yet its true weight remains a quiet mystery. Fact 7. Recent measurements suggest the Milky Way may actually be heavier than the Andromeda galaxy. For many years, astronomers assumed that Andromeda, which appears slightly larger and brighter than our galaxy, must also be more massive. But newer measurements hint that the Milky Way's dark matter halo may be broader and denser than previously believed. If these calculations prove correct, our galaxy could actually outweigh Andromeda despite looking more modest. This matters for predictions about their future collision. When two galaxies eventually merge, their relative masses will shape how the encounter unfolds and what the final combined galaxy will look like. The Milky Way may appear gentle in photographs, but beneath its quiet spiral arms, it carries more gravitational weight than we once imagined. Fact 78. The Large and Small Magellanic Clouds may be visiting the Milky Way for the first time. These two bright satellite galaxies, visible from the southern hemisphere, have long been thought to orbit our galaxy, but recent evidence suggests they may actually be newcomers, captured only recently in cosmic terms. Their velocity and trajectory through space hint that this could be their very first close approach. If true, they are not long-standing companions but distant wanderers just now falling under the Milky Way's gravitational influence. Their arrival has already disturbed the outer disk and contributed to the warp shape we observe today. The sky is full of first encounters. Fact 79. A vast ribbon of hydrogen gas called the Magellanic Stream trails behind the Magellanic Clouds. Stretching behind these dwarf galaxies is an enormous stream of gas extending over hundreds of thousands of light years. This structure, invisible in optical light but bright in radio wavelengths, was pulled away by tidal forces as the galaxies passed close to one another and to the Milky Way. The stream wraps across the southern sky in curves and arcs, like a long, trailing whisper of motion and loss. This stripped material may one day feed new star formation in our galaxy, or settle into the halo like a thread of memory connecting different worlds across vast distances. Fact 80. Some gas clouds orbit the Milky Way in polar directions, passing above and below rather than around. Not everything in our galaxy follows the orderly flat plane of the disk. Certain clouds of gas, and even some stars, move on highly inclined orbits that carry them in unusual paths through space. These polar orbits likely came from past mergers, when smaller galaxies or stray clouds were captured at odd angles. Over time, they continued moving on tilted paths like comets circling a planet. These misaligned orbits serve as visible records of disruption, reminders that the galaxy is not a closed system, but an evolving structure shaped by unpredictable flows of cosmic history. Fact 81. Giant shells of gas surround regions where powerful bursts of star formation once occurred. In several areas throughout the Milky Way, astronomers have discovered enormous spherical shells made of gas, some spanning hundreds of light years. These shells are remnants of episodes when clusters of massive stars formed together, lived brief lives, and exploded in rapid succession. Their combined stellar winds and supernova carved huge cavities in the interstellar medium, blowing material outward in all directions. Over time, the expansion slowed, but the shells remain as ghostly bubbles marking where the galaxy once burned bright with intense stellar birth and death. These are fossils of cosmic fireworks, still echoing faintly in the cold. Saxrum. D2. In the densest regions of the galaxy, stars occasionally collide directly with each other. Space is vast and stars are small, making direct collisions extremely rare. But in the tightest neighborhoods, such as the cores of globular clusters where hundreds of thousands of stars are packed into small volumes, stars can pass close enough to interact and even merge. When collisions happen, the results can be dramatic, producing bursts of light, the merging of two suns, or the formation of unusual objects called blue straggler stars that appear younger than their neighbors. These collisions are uncommon, but over billions of years, the crowded stellar cities can rearrange themselves through gravity and chance. In these packed regions, time moves differently, and space is never quite empty. Factor 83. Binary star systems can be torn apart by powerful tidal forces. Many stars exist in pairs, orbiting each other in gravitational partnership. But even this bond can be broken under extreme conditions. If a binary system passes too close to the supermassive black hole at the galactic center, or through a dense cluster, tidal forces can disrupt their orbit. One star may fall inward and vanish while its companion gets flung away at high speed. In some cases, the ejected star is hurled completely out of the galaxy, becoming a rogue traveler speeding through intergalactic space. These stellar breakups happen silently in places we rarely observe, quiet endings to ancient partnerships torn apart by gravity's indifferent hand. Fact 84. Some stars reach escape velocity and leave the Milky Way entirely, never to return. Most stars remain gravitationally bound to our galaxy throughout their entire existence, but occasionally a star reaches speeds exceeding 500 kilometers per second and escapes forever. These hypervelocity stars are rare, but real. Some get ejected by interactions with the central black hole. Others are flung away by three-body gravitational encounters or by supernova explosions in binary systems. Once free, they travel alone into intergalactic space, becoming tiny lighthouses drifting far beyond the spiral's edge. They carry the galaxy's memory outward, solitary pilgrims journeying through the great dark between galaxies. Fact. E5. The Milky Way contains stars that originally formed in other galaxies. Not all stars within our galaxy were born here. Some originated in distant galaxies and were captured during ancient mergers or flung into our halo from other regions of the local group. These intergalactic wanderers often move on unusual orbits far from the disk, tracing paths through the outskirts. They can be identified by their composition or motion. Stars that do not quite fit local patterns. Like cosmic immigrants, they bring stories from other environments, other histories, other skies. The Milky Way is not sealed off from its surroundings. It is a living mosaic, slowly stitched together by time and motion. Fact 86. Gas cycles between the disk and halo in a process called the galactic fountain. Above and below the bright disk, material rises and falls in a quiet loop. Supernova explosions and stellar winds heat gas and eject it upward into the halo, where it cools, condenses, and gently rains back down over millions of years. This cycle stirs the interstellar medium, redistributes heavy elements created in stars, and helps regulate ongoing star formation. It is a quiet respiration, a breathing motion between the dense plane and the vast halo. The galaxy does not simply spin, it circulates and exhales and inhales, keeping its structure in motion across immense spans of time. Fact 87. Interstellar dust grains carry complex organic compounds, the chemical building blocks of life. Within clouds of dust floating between stars, scientists have detected complicated carbon-based molecules. These include substances like polycyclic aromatic hydrocarbons, simple sugars, alcohols, and more. Though not alive, they are chemically rich, formed in atmospheres of dying stars or within cold clouds shaped by radiation. These tiny grains, carried across light years by galactic winds, settle into gas that forms new stars and planets. Some may have fallen onto early Earth. The galaxy's dust is not just debris, it is cargo of potential drifting silently through darkness. Fact 88. Star. Forming clouds may naturally seed solar systems with ingredients necessary for life. The birthplaces of stars are also where worlds begin. As planetary systems form from collapsing clouds, they inherit chemical fingerprints from their parent nebula. If that cloud contains water, carbon compounds, and other building blocks of biology, those ingredients may end up in comets, asteroids or planets. Some regions of the Milky Way are especially rich in such prebiotic chemistry. We do not yet know how common life is, but conditions for it seem to arise naturally. Seeds of life may be scattered far and wide, tucked into the galaxy's coldest cradles, waiting for the right place to grow. Fact 89. Some stars rotate hundreds of times faster than our Sun does. Most stars spin at moderate rates, but some rotate incredibly fast, completing full rotations in just a few hours. These rapid rotators are often young, massive, and unstable, with equators that bulge from centrifugal force. A few reach such high speeds that they fling material off into space, forming glowing disks around themselves. Our Sun rotates once every 25 to 35 days depending on latitude. But these fast-spinning stars rotate hundreds of times more quickly, approaching physical limits where the star would tear itself apart. Their internal structures and evolutionary paths differ significantly. Their lives may be brief, but while they last, they spin like blazing tops in the dark. Factor 90. The Milky Way is tilted relative to the plane of our solar system. From Earth, the galaxy arcs across the night sky in a graceful band of light, but it does not align with where the planets orbit. The galactic plane is tilted about 60 degrees relative to the ecliptic, the path traced by Earth's orbit around the Sun. This tilt is why the Milky Way rises at an angle, and why its position shifts with seasons. We are part of this vast galaxy, but our own small system is angled somewhat askew, a tiny tilted boat drifting through a larger spinning sea of stars. Fact 91. Some stellar remnants in the halo are older than the galaxy's main disk structure. Among faint stars in the halo region, astronomers have found white dwarfs, cooling cores of once luminous stars, that are older than the Milky Way's thin disk itself. These ancient remnants formed when the galaxy was still young, before its main structure had fully settled into place. Their existence hints at an earlier era of star formation, a deeper history etched into the outer halo. They have burned for billions of years, slowly fading, carrying with them a quiet residue from a time when the Milky Way was still gathering its shape. The disk may be bright, but the halo remembers further back. Fact 92. The farthest stars in the Milky Way orbit well beyond the familiar spiral structure. Our galaxy's most distant stars travel far beyond the spiral arms, tens or even hundreds of thousands of light years from the centre. These stars move through the halo on slow, wide paths, taking billions of years to complete single orbits. Many were likely captured from smaller galaxies during past mergers, now drifting in the outermost reaches like distant sentinels. They are faint, sparse, and far between, but they help define the galaxy's true size, shape, and gravitational reach. The Milky Way extends deep into darkness, shaped by wanderers at its edge. Fact 93. The shape of the Milky Way is lopsided in multiple ways. Though often pictured as symmetric, the galaxy is subtly unbalanced. One side of the disk is thicker. Spiral arms are uneven in brightness and length. Even the stellar halo is slightly off-center. These asymmetries likely arise from gravitational interactions with the Magellanic Clouds, with clumps of dark matter, or from past mergers. The galaxy is not a perfect pinwheel. It is a living structure marked by tugs and twists, like a spinning dancer whose skirt has been caught by wind. Beauty lies in that irregularity, graceful imbalance sculpted by time. Fact 94. Astronomers map the galaxy using variable stars that pulse in regular rhythms. Certain stars expand and contract like slow, luminous heartbeats. These are variable stars, and some types have well-known relationships between their brightness and pulse period. By measuring how long a star takes to brighten and dim, astronomers determine its true luminosity. Comparing that to how bright it appears reveals its distance. These stars serve as cosmic measuring sticks, helping map the shape, structure, and scale of the Milky Way. They are lights that measure darkness, blinking beacons scattered through the spiral. Fact 95. The Gaia mission is creating the most detailed map of the Milky Way ever made. Launched by the European Space Agency, the Gaia spacecraft measures positions, motions, and brightness of over 2 billion stars. It reveals the galaxy's three-dimensional structure and motion through time. Gaia has uncovered streams from shredded galaxies, mapped the disk's warp, and traced the sun's orbit with exquisite detail. With each new data release, our understanding deepens. What was once a hazy smear of stars becomes a sharp, living map. It is astronomy's most ambitious star chart, a quiet revolution unfolding among stars. Fact 96. The galactic plane marks the densest concentration of stars visible from Earth. On a dark night away from city lights, you may see a hazy river of starlight crossing the sky. That is the galactic plane, the thickest slice of the disk. It is not a line but a depth, a vast flattened band where most stars reside. Through this plane, stars are densely packed, dust is layered, and star formation is common. From our position, we look along the grain of the galaxy, peering through its richest corridors. This band is not just beautiful, it is the crowded, humming heart where most stellar life and death occurs. Fact 97. The night sky appears brightest when looking toward the galactic center. The core of the Milky Way lies in the direction of Sagittarius constellation, a rich glowing concentration. From Earth, we cannot see the very center in visible light because dust blocks our view, but the region glows brightly in infrared and radio wavelengths. Even with unaided eyes, the area appears more crowded and luminous, filled with overlapping light from billions of stars. We orbit far from this center in a quiet suburb, but when we look inward, we glimpse the crowded city at the galaxy's heart. Fact 98. We see the Milky Way edge on from our position inside it. Because we live within the galaxy, we cannot look down on it from above. Instead, we see it from inside, a flat ribbon of stars stretching across the sky, curved only by horizon. This edge-on view compresses the galaxy into a single arc, making its full structure hard to grasp. It took centuries of observation and mathematical deduction to realize the spiral we belong to. From Earth, we gaze through the disk like standing in a forest and looking along the line of trees. We do not see the shape we are part of, only vastness surrounding us. Fact 99. The galaxy holds far more than we can ever possibly observe. Even with our most sensitive instruments, we glimpse only a fraction of what exists. Light is blocked by dust, motion hides in silence. Dark matter outnumbers luminous stars. Between every star lies emptiness, and within every empty space potential. The Milky Way is not just what we see, it is what we suspect, what we infer, what we long to understand. It holds ancient light, future stars, drifting worlds, and questions still without answers. Fact 100. Within the vastness of the Milky Way, somehow we find ourselves one planet among many. We orbit a quiet star in a modest spur between grand spiral arms. We float through a story too wide for eyes to capture completely. And within that immense vastness, we exist. We look up. We wonder. We try to understand our place in this turning spiral of light and shadow. The galaxy does not notice us, yet we are part of it. Made from its matter, shaped by its history, living briefly within its endless motion through space and time.